When a bullet is fired from a rifle, it exits the gun with approximately twice the speed of sound. In this video, we will discuss how high can different bullets and projectiles go, can any of them reach space, and is it physically possible for a projectile to escape Earth's gravity completely? It is generally agreed upon that space starts at 100 kilometers, also known as the Kármán line. For any object to escape the Earth's gravity, it requires an initial speed of 11.2 kilometers per second, not accounting for the atmosphere. The fastest bullet fired from a rifle can achieve a speed of 1.2 kilometers per second, way below the escape velocity. The bullets fired from rifles can reach a height of approximately 3 kilometers, which comes inside the troposphere, the first layer of Earth's atmosphere, which extends to 10 kilometers in height. When a 155 mm artillery round is fired for maximum horizontal range, it can reach a height of about 10 kilometers, but if it is shot at a very steep angle, the height achieved could be around 15 kilometers. Most commercial aircraft have a maximum approved altitude of around 12.8 kilometers, also known as the service ceiling. However, the Concorde airliner could maintain a supercruise at an altitude of 18.3 kilometers. The longest range artillery gun, called Paris gun, built by the Germans to bomb Paris, fired at a muzzle velocity of 1.6 kilometers per second and could reach a maximum altitude of 42 kilometers up into the stratosphere, more than twice the service ceiling of Concorde. But that still did not reach space. However, there was a high-altitude research project called HARP, a joint venture of the United States and Canada. This project used very large guns to fire projectiles into the atmosphere at very high speeds. In 1966, the HARP gun launched an 84 kg projectile at 2.1 kilometers per second, sending it briefly into space and setting a world altitude record of 180 kilometers. So a projectile can reach space, but is it possible for a projectile to escape Earth's gravity completely? As we know, the Earth's escape velocity is 11.2 kilometers per second, and when air drag is taken into account, a bullet-shaped object would require about 13.5 to 15 kilometers per second to escape Earth's gravity completely. But there is a limit to how fast you can get something using chemical explosives. However, there is one other type of gun called railgun, which uses electromagnetic currents to accelerate projectiles instead of chemical energy. Although railguns have no muzzle velocity limit in theory, but they do have practical limitations of power, heat, and structural integrity of the gun. The US Navy has tested a 10 kg aluminum projectile that reached Mach 7, or about 2.4 kilometers per second. It has broken the world record for the most powerful projectile shot. Even if all the practical limitations of railguns are overcome and it becomes possible to shoot a projectile at the escape velocity, the projectile will still not be able to escape Earth. It will most probably vaporize in the atmosphere after not going very far. In order to prevent complete vaporization, the mass of the projectile would have to be significantly increased. So making a projectile escape Earth's gravity is a very difficult and close to impossible task. But let's get out of the atmosphere and say we are on the space station almost 400 kilometers above Earth. Will a bullet shot in the direction of the orbit escape Earth? The answer is no. The escape velocity required at the height of International Space Station is still almost 10.8 kilometers per second. The International Space Station is traveling at 7.67 kilometers per second, and the fastest bullet travels at 1.2 kilometers per second. So the resultant speed of 8.87 is still less than 10.83 kilometers per second required. The bullet will only go into a higher orbit than the space station around Earth.